Hi everyone and welcome back. We are up to tutorial number 7, so we're getting near the pointy end of the course now. And for the next 3 weeks, so for today, tutorial 8 and tutorial 9, we're going to be looking at two-way ANOVA. So this is going to be quite a detailed exploration of two-way ANOVA. And this analysis differs a little bit to one-way ANOVA, so a little bit to the type of ANOVA we've been doing the last 2 weeks, in that two-way ANOVA can handle two IVs at once, whereas in the past 2 weeks we've looked at a single categorical IV at a time. So two-way ANOVA can take two categorical IVs. Now if you extend this naming convention forward, a three-way ANOVA would have three categorical IVs, a four-way would have four IVs, and so on. But in this course you guys will just be looking at the two-way. So let's load up our dataset and then let's begin. Let's see if my data's there. There it is. Excellent. Let's bring in the command box as well. So one of the things that we can do in a two-way ANOVA that we can't do in a one-way is we can actually look at the relationship between our two IVs. And so what this allows us to do is to see whether or not the way that the DV score spread across one IV actually changed depending on the levels of the other. So for example, today, we'll talk about this in more detail in a second, but we're going to be looking at gender, alcohol, so the amount of alcohol a person consumes, and how attractive they see other people. And so what we might find, and what we would almost expect, is that as alcohol levels go up, attractiveness ratings are going to change. But there is a possibility that the relationship between the amount of alcohol you consume and how much attractiveness change actually depends on whether or not you're male or female. So we might find that males show a stronger relationship, whereas females might show a weaker one. And so this ability to actually tease out and say, well, the relationship between one IV, such as alcohol, and the DV attractiveness might actually change depending on the levels of another IV. We call this an interaction. And they're really, really crucial because they change the way that we approach the interpretation of our data. Alright, so we'll get to explain that in a little bit more detail later on, but let's just begin at step 1 and we'll work our way through. So as I've already mentioned, this week we're looking at a study that took in men and women into their study and then gave them different amounts of alcohol. They were given either no alcohol, 2 pints of beer, or 4 pints of beer. And then they were asked to rate the attractiveness of someone of the opposite sex. So males were given females, females were given males to rate. The hypothesis was that as consumption of alcohol increases, ratings of attractiveness of the opposite sex would be affected. Or would it be affected? That's a research question. There's no hypothesis. The sampling population is men and women. Just in general, we're giving them alcohol so we can assume that they're adults. Step 3, data summary. So our DV is the attractiveness rating of someone of the opposite sex. In our dataset, this is called attract, and it's numeric. Our first categorical IV is the gender of the rater, so this is the person who's consuming the alcohol. We call this sex in our dataset. It's in long format, so we have a single column called sex with zeros and ones for males and female. It's categorical, it's nominal because we are not sexist. We are not going to assume that males are better or worse than females. It has 2 levels, male and female, and it's between subjects because you can't ethically force a person to be both male and female in a study. Level 0, so what a 0 represents in our dataset is someone who is male, and a 1 represents someone who is female. IV number 2 is the number of pints of beer consumed. We're calling this pints in our dataset. It's represented in long format, so again we'll have a single column with 0, 1, and in this case 0, 2, and 4, representing whether or not they had 0 pints of beer, 2 pints of beer, or 4 pints of beer. This is a categorical variable. It's also ordinal, and it's ordinal because we're going 0, 2, 4. Well, it's not the coding, it's literally 0 pints, 2 pints, 4 pints. So it has 3 levels, 0, 2, and 4, and it's between subjects because people were allocated to one of these amounts of alcohol, not all 3. So if we bring all this information together, we have what's called a 2x3 factorial design, where we're manipulating gender and the amounts of alcohol consumed. So last week when we were talking about ANOVA, a one-way ANOVA, I said the design was experimental. And here I'm saying it's a 2x3 factorial design. I'm not using the word experimental. This isn't a bad thing. Once we start talking about factorial designs, we are implicitly talking about experimental designs, either experimental or quasi-experimental. Because whilst the manipulation of pints of beer is experimental, because we can control that, gender is a quasi-experimental variable. We are manipulating it through quasi-experimental means, in that people come to the study as male or female, and that defines their category. We're not forcing them to be male or female. So if you see a factorial design, it means the design is experimental or quasi-experimental, and it's 2x3. Now 2x3 doesn't mean 2 variables with 3 levels. It actually means that my first variable has 2 levels, and then my second variable has 3 levels. So if I had a third variable, and let's say it had 6 levels, I would say 2x3x6. If I had a fourth variable with 2 levels, again, it would be 2x3x6x2. So each number here represents a variable. So this here is the first variable, then the second, and then we had a hypothetical third and fourth. The actual value of the number represents the number of levels. So I have a 2 here because I have male, female. I have a 3 here because I have 0 pints, 2 pints, 4 pints. So it's 2x3 factorial design. The research question involves comparing more than 2 levels of 2 categorical variables together. So now that's the clue, it's that we have 2 categorical variables. Our DV is numeric, our IV is a categorical. So it's a two-way between subjects ANOVA. It's important to say that it's between subjects, because there are many, many different kinds of two-way ANOVAs. Between subjects is just one of them.